So these notes today, coordinate geometry, we named that quadrilateral. I'm going to classify a quadrilateral as a parallelogram, rectangular, rhombus, or square using the following steps. Step 1, check congruency of diagonals. Step 2 is to check the slopes of diagonals. Now there's other way to prove these quadrilaterals to be a parallelogram, rectangle, rhombus, or square, but we found the easiest way for y'all and the most consistent way to help y'all remember just two things is to check the congruency of the diagonals and then check the slopes of the diagonals. Based on what they tell you, you'll figure out which one of the four it is, and I'm gonna roll through all four and talk about those things with you. But before we go through that, let's do a little reminder out to the side for ourselves, make sure we still remember what slope is. So a perpendicular slope. So when we're doing slopes of the diagonals, remember specifically for the rhombus and the square, the diagonals have to be perpendicular because you got all right angles in here for these two. So for these two, we need to be looking for perpendicular slopes for the rectangle, not the rectangle, excuse me, for the rhombus and the square. If that's the case, y'all got to remember what a perpendicular slope looks like. 1, I tell you the slope of one line is 2/3. What's the slope of the perpendicular line? -3/2. Thank you, Juan. Remember those perpendicular slopes off the reciprocal. Chris, I'll tell you the slope of a line is -3. What are you going to tell me the slope of the other line is? Perpendicular. No, Faith. Just looking crazy. Go ahead, Nasir. Thank you, sir. 1/3. Opposite reciprocal. Just make sure you remember. So that's what we're checking for. Like for those, if we get like opposite reciprocal slopes, that's when we can consider whether it's a square or a rhombus. Alright, let's talk about these though so we'll understand what we're looking for on each one. Because the mixing and matching goes different from each one. So the first one is the regular parallelogram. For a parallelogram, the two things we're looking for: diagonals that are not congruent, and here we should edit this, but we didn't. We're not looking for and the diagonals bisect each other. We're not looking to prove that part. The other part we're gonna prove, we need to add this in. The diagonals are not congruent, and then the diagonal should not. We're gonna say not perpendicular either. So add not perpendicular in on the end. So for a parallelogram, we're going to check to see that the diagonals are not congruent, meaning there should be different lengths, and then the diagonal shouldn't be perpendicular either. So those two things, and we do that by the slope. Checking the slopes. If that's the case, then we have a parallelogram. The second one, the diagonals are congruent if it's a rectangle. So when we check our diagonals on a rectangle, they should be congruent. And the other thing we need to do is check for perpendicular. They should not be. The diagonal should not be perpendicular on a rectangle either. So add that in at the end, not perpendicular. The bisect each other part, I mean, we could check that, but that's the hardest part to do. We don't need to do that. If we do these two things, diagonals are congruent, check to see that, and check to see that they're not perpendicular, then we can prove rectangle. And on the other two, they're written fine. Case 3 says diagonals are not congruent. This is for a rhombus. The diagonals won't be congruent, but they will be perpendicular. The diagonals are perpendicular. Yeah, it's written there on this one. So on this one, the diagonals are perpendicular. So we'll show perpendicular slope here if we prove that's a rhombus. And in the last case is for a square. Your diagonals will be congruent for the square. They'll both be the same length. And the diagonals will be perpendicular. So they'll be opposite reciprocals of each other. So those are the two things we're basically proving on each one. These two steps right here. We're proving that we're looking to see if the diagonals are congruent, if they need to be or not. And then seeing if the slopes of the diagonals are perpendicular or not. And that'll tell us which one of these shapes it is. Or at least prove it. Honestly, by the time you finish drawing it, you'll know what shape they're trying to get you to prove for. But then after that, you got to make sure your shape meets both of these requirements by proving it with the work. So honestly, the work is going to feel extra, but it's what you have to do for us at least. Now on the test, if you want to just do your best multiple guess based off what shape you think you see, you can do that. But for us, you got to show your work right now. So number one says, given the vertices, determine the quadrilateral most specific classification. So graph first. And you ain't gotta wait on me to do that. You can graph. Make sure you label too. Other thing, after you connect your lines and make a shape, put your diagonals in. So from B to D, make a diagonal. From A to C, make one. You're more than likely going to want to use a straight edge on this. Your idea will work perfectly if you have one. Alright. Once you get your shape drawn and then you put your diagonals in, for each one of these, let me go ahead and say it now. When you're doing the check to see which shape it is, what classification it is, you need to draw your diagonals in because everything's going to be based off you doing the diagonals, finding the length of the diagonals and then finding the slope of the diagonals. So you need to draw your diagonals in. I say that because I said this last period, and maybe I didn't say it enough times. Kid came up to my desk during the practice part, asking me, couldn't figure out what he was doing. He didn't draw his diagonals in. Once he drew those in, he was okay. We're drawing the diagonals in. Everything, all the checks we're doing are based off the diagonals. So, looking at this shape the way it's drawn, like I say, it's obvious to you that the best classification you can give this shape is a rectangle. But you just want to be sure, you want to make sure, so you go through and you check the length of your diagonals first. To do that, these are diagonals and they're on here slanted on the graph, but y'all should still know how we gonna go about finding the length of these diagonals. We're gonna make our triangles and we're gonna do Pythagorean theorem. So we want a triangle from A to C. On this one I'll go up here and then I'll go over this direction. Make my triangle from A to C. I'll do a count on that one real quick. I went one up. I went to the right. 1, 2, 3, 4, 5, 6, 7. So 1, 7. And then I need to do one for BD as well. Yeah, up here. This one. So from BD, I'll come out this way. BD, I come out here, and I go up. For BD, my counts will be, so I went to the right 5, went up 5, yeah. So in this one, my numbers are different. I got 1 and 7 and 5 and 5. So I want to finish doing my check on this one to make sure that these two are congruent, because my numbers are different. The numbers being different doesn't necessarily mean that the two diagonals ain't gonna be the same length. It's just you got different numbers because the slopes are different. I'm doing AC first, checking for that one. So start up here. AC will be 1 squared plus 7 squared equals C squared. 1 is 1 plus 749 equals C squared. Add that together, 50 equals C squared, square root. Now in this one, we didn't ask for simplest radical form, and I have to check and I'll let y'all know before we do the test. I can't remember. I don't think we asked you for simplest radical form on that either. Because I don't really think we care about that on the test. We're just going to ask you what shape you see, honestly. So I was just letting the kids give me decimals today. I think we did 7.1 on this one. And then the other one is BD that you need to check, that diagonal. BD was 5 and 5, so 5 squared plus 5 squared equals C squared. 25 plus 25 equals C squared. 50 equals C squared, square root. And 7.1 again. So obviously both of these diagonals, AC and BD, are the same length. Just need to show our work and prove that. So we've checked the diagonals for congruency. They're good. The other piece you have to do is check the slopes for perpendicular. For this to be a rectangle, we don't want our slopes to be perpendicular, so they shouldn't be. We're just going to check them. So for the slopes, let's do the slope of AC first. The slope of AC. AC is this diagonal right here. From left to right, I see it going up. So I'm doing rise over run. My slope is 1 over 7. Honestly, the count you did for your triangles is your slope. You just gotta make sure you do the rise over run. So do the rise part first. And if it's a fall, you need to put a negative in front. We'll talk about that when we get to it on another one. But yeah, so rise over run. And this one is already counted for me, 1 over 7. Can't reduce it. For BD, my slope of BD, we counted 5 and 5, but that can be reduced to what? Louder? 1, right? So my slope of BD would be 1. Alright. So my rise was 5, my run was 5 on BD, which is 5 over 5, which is 1. So we're just comparing the slopes. One of these slopes perpendicular? No, and they shouldn't be. It's a rectangle. You don't want perpendicular. I heard somebody say yes. Embarrassing. No, the slopes are not perpendicular, and you don't want them to be because it's a rectangle. So these two things qualify as for a rectangle. Congruent diagonals, but the diagonals are not perpendicular. Rectangle. Alright, sliding on. Next one, number 2 on the back. Determine the most precise quadrilateral by placing the check in the box with the coordinate points. So out here they give you multiple choice, but it was already multiple choice anyway because we knew the last one was going to be one of those 4 things too. So draw it out. This one going to go quick too. Graph it. -2, -7 here. 1, -5 here. 4, -7 here. Yes. 1, -9. See. Oh, I wasn't graphing with you. But just know how to graph. Well, that's on you. Send you back to D'Angelico. Once you finish graphing, you should see the shape. What shape you see, Chris?
What shape you see?
You got four options, though. Ain't no trick. Yeah, you should see a rhombus. That's my last period said you got that square. No, you should see a rhombus. Alright, reason I want you to see that because you need to know what you're trying to prove for the rhombus on the front. For the rhombus, you want to prove that the diagonals are not congruent and that they are perpendicular. So those are 2 things you need. Like I said, don't worry about that bisect part. You're just worrying about diagonals being either congruent or not congruent and perpendicular or not perpendicular. But for the rhombus, the qualifications are diagonals are not congruent and then diagonals are perpendicular. So let's make sure those 2 things are correct and then we can call this a rhombus. This one's on here. I draw my diagonals in. The way this one was graphed, though, it's graphed on the graph straight, which makes life a lot easier. So you draw your diagonals in. One of your diagonals is horizontal. The other one is vertical. And if that's the case, then you can easily count your 2 diagonals, right? QS, we can do that real quick out to the side. QS is equal to what? Not everybody at once. QS is equal to what?
230.
What?
Oh, I meant, oh, shoot.
Yeah, 6. What's wrong with y'all? RT is equal to what? What? Those are my 2 diagonals right there. I mean, even though they just the way the shape is on the graph, they're just straight up on here, so it's easy to do. So 6 and 4, there's no math call for on that. We didn't need to do Pythagorean. He's on here straight, so we can just count them. And then the other part is checking for the slopes to see if they're perpendicular. So on this one, let's see if y'all remember. Slope of QS. What's the slope of QS? 0, yeah. QS has 0 slope. Slope of RT. I can't hear you. No, not 0. Undefined. Yeah, because one is horizontal and one vertical. I mean, I'm just messing around with y'all to see if y'all remember these words, but you should know just by looking at this. Are the slopes perpendicular? What? Somebody said no? Yeah, they perpendicular. You don't see the right angles? So, it makes our qualifications for a rhombus. For the rhombus, you need to have diagonals that are not congruent and perpendicular slopes. On this one is 0, one is undefined, meaning one is horizontal, one is vertical. That means they are perpendicular. So on this one, we can check off rhombus. We proved that too. It wasn't much work to prove on this one. Just counting. Number 3. And number 3, we will ask you something like this on a test. This ain't no triangle. Number 3, it says with points J, K, and L, find M if the points given form a parallelogram. So on this one, well, parallelogram J, K, L, M. They give you 3 points. They want you to find the 4th point if you know the shape is going to be a parallelogram. But we will ask you one like this on the test. So make sure you're paying attention. Irvin, you paying attention, bud?
I want a silly rabbit.
So these are the only 3 points we have, which is J, K, and L. You already know where it's at? See if you can figure it out without me. Now you can't draw the whole connection because you're missing that other point, but it may help you to connect. Go ahead and connect J to K and K to L. I just connect by the way it's named. It's called JKLM, so I'm going J to K and then K to L. I'm just do those 2 connections just so I can see it a little bit better. See how the shape is forming. So it's supposed to form a parallelogram. You off? But that's fine. Let's see if you got it. No, y'all both off. Darn. Thought y'all might be able to see it without me. Still up. Now, looking at this, the way this is drawn, you can kind of tell yourself where that other point is going to be at. That other point, M, is going to be in here somewhere. You got to figure out where that point is going to be. Still off. The way I would do it. So, I know it's a parallelogram, so I know certain sides are parallel. Like I know JK. I know this side JK is going to be parallel to side what is it? ML. Whenever I find M, I know JK is going to be parallel to ML wherever M is. Shh, y'all listening? So if I know this is going to be parallel, they're going to be parallel because they have the same exact slope. If they have the same exact slope, I can find the slope of JK and then recreate it up at the top from L to M, and then I'll figure out what M is. Let me show you what I'm saying. I know J to K is going to have the same slope, so I'm just going to do a slope for this. I'm going to just draw a triangle like we've been doing. Draw a triangle from here to here, from J to K. And then I'm going to count that too. I'm going to count triangle 3 this way, I went 3 to the right, and then I went 3 up. I'm going to go up top and create that same triangle again. But when you understand when you go up top, you kind of got to draw it backwards, yes. Because I really got the point K is going to be similar to the point L up here. So when I draw my triangle again, I'm going to draw it coming down 3 from L, and then I'm going to go back 3. Redrawing the triangle up here. So 3 and 3, that's good. Once I do that, I can land on my new point right here. And that should be point M for me. And then we draw it in, it should look like a parallelogram. So that's my point M. Point M is at, what is that? Thank you. 8, 7. Not 7, 8, not 6, 9, not 6, 4. So you on that one you just recreating, and I know for a fact we do one like that on a test. There's another one we do on a test, but we didn't put it in y'all notes today. I'm not sure it to you tomorrow when y'all do your activity. Yeah, I told you this test a little while. I ain't gonna lie to you. So I'm gonna pause for a second. I want to show y'all the first one in y'all practice, and then I'm done after that. Oh, I'm just pausing the screen. Hold on, I ain't pausing.